Hi, Michael Gunna to show us a real analytics project using PySpark. As a part of Michael's assignment in Spark of his master degree in IE University, the Business Analytics and Big Data candidacy. He gonna to explain how he worked with a real retail data to extract interesting insights using Spark environment and scripting in PySpark.
Hello, thank you Jack for the introduction. As Jack mentioned, we are going to explain retail data analytics project today, and this project will be based on Spark environment using the Spark virtual machine and Jupyter Notebook using PySpark. Today we are going to take it step by step from the beginning till the end. So the first thing we are going to start our virtual machine. This one is available and you can download it very smoothly from internet. We will start it as headless start and we can see the preview here. Once this machine starts, we will start our Jupyter Notebook through the web browser. Let's try to open Notebook here. And for sure, this environment will be based on the Spark. Will be based on a Spark machine. So before everything, we need to see what is exactly the data and the project will be based on. This is the retail data analytics and a project, and it is available on Kaggle. This project target historical data about 45 stores located in different regions, and each store contains number of departments. We are going to see exactly what is the data, what is the content of this data, and what is exactly the insight we are going to show in this session. So I have only an individual assignment folder. I'll go here to do upload to all the data files have been downloaded from Kaggle, and they are 3: features, sales, and stores. And then I'll create a Python 3 file, but actually I have it ready, so I'll only open it directly and show you. So what we have actually in this project, we will discuss how we can do PySpark environment setup, extract our data set, show their structure, run a quick summary for each data set, and then doing the data cleansing. And for sure, this is very important, and it is called data preparation as well. We'll do the merge for all data sets to only one data frame. Apply our filters and use some UDFs, and then we'll show some insights. Very quickly, these insights will be top 10 stores, top 10 store per sales, order the month per their sales, top 10 departments, and full summary for each month about with average of temperature, fuel price, markdowns. And the last one will be average consumer price index per month. Then the first thing, this is a PySpark environment setup, and here we call some libraries and some functions to use in our them on our next steps. And here we use also some functions, specific functions from SQL functions to manipulate our data. As we said, the data is coming from Kaggle. We will read our data from CSV files, and we will find some different steps for each data set, and we can see here is the information from each data set separately. And here we will do or show quick summary for each table. As we can see, here is a summary is having count, mean, standard deviation, minimum, maximum, and all of this, and for sure the quartile. Here, if you can see in the minimum, of this date, it is 1st of April 2011, and the maximum is 31st of December 2010, which is non-logical. So that is why. This is because the date is actually as a string format. So in this case, we are going to convert our date into the timestamp format. This will help us to understand the date properly. Here is also summary for stores and features. And as well, we can see also the date have a problem here as well. So in our data cleansing and our data preparation, we are going to fix this problem. Here we are using Unix time, using the Unix timestamp function. This is for converting the date, this date into the proper format. We can see here, this is the date, the old date, and here is the new date, okay, and including time. It is not needed here, yes, but it is there by the way. So we can see here the same thing on features table, and then we can see the difference here. Here is the minimum became 5th of February 2010, and the maximum became 26th of October 2012. So here is the old one, and it is there as the same. So that is why we will drop this column, date column, because it is not needed anymore, and we will drop them because it is not needed. So now, for sure, the same happened, or same have been applied for feature dataset. And now we are going to merge our dataset into only one data frame to work on it. And this is for sure using join, and our store will be our key. And for the dates, or for metadata comes from feature, will also join with date, because the date actually point to the week dates. Here is the last, you can say this is the last information, or the last shape of our data frame. We can see here, this is the number of records. It is 420,000. And this is, I think, a good number. It is not a big data or huge volume, but we can work on something like this. Will be very interesting. Here is a splitting of our data, because we have partial information from 2010 and 2012, which is not full year. So that is why we will use here splitting using a where condition to filter on only the data that is related to 2012 as a year. Here we use a UDF, which is user-defined function, to identify a function to show the thousands, millions, billions, and the trillions as readable numbers. And we will see now why we do that. As you can see here, this is the first insight, okay? And here we are getting top 10 stores per sales in 2012 for sure. All our data will be based on this year. So we can see this is actually the total of sales, which is not readable, because we can see here, this is a very big number as well. E is not readable. So we can see here the difference. Now we can see this one is 111 millions, 110, and so on. For sure, we are ordering descending on the submission, or based on submission of weekly sales. Same here, ordering the month per their sales, starting from also the descending based on the sales, weekly sales. So this is the highest number, and this is the lowest. So we have here the biggest sales, or the highest sales, it will be always in December, and in the lowest sale will be in Jan. For sure, we have ordering here based on the revenue for the sales. Here is the top 10 departments, and for sure these departments actually are the participated departments for the sales during the year, because we don't have a full description for each department, because maybe this is the objective of this data. They don't have full information, but actually we have the department number. And as well, also it is ordered by submission of weekly sales. Here is because we have multiple information or many information is related to each month. So that is why we did a vertical analysis is related to each month and giving us the average temperature, average fuel price, and markdowns, and unemployment, and so on. So we can see actually here each month has their statistics based on the feature or the feature metadata information. Then we do the average consumer price index per month. This is the average, and also it is descending, and it is showing this the highest index, consumer price index. It was in December, and the lowest was in January. As we can see, actually, this is increasing data. So it is in the same sort. So it's starting from Jan till December with the same sorting, and the amount is, or the index is going increased. The last thing, or last insight we have extracted from this data set is sales per store. And this one is showing each store type with their total sale. As we can see, for sure, type A, which is maybe the biggest stores, they have the biggest and highest sales during the year. Thank you so much for enjoying and watching our video. I wish you enjoy the video. Please, if you have any question, let me know. Thank you so much.